is Mr. Hassan's Maths channel. I'm now answering question number 7 from the October-November 2016. This is the paper 1, the Pure Mathematics 1 paper from Cambridge, 9709. This is paper 1, variant 2. And it is also the question number 9 from my end of topic worksheet for my P1 collection. And it's worksheet number 12, which is further differentiation, differentiation 2. So we're told here that the equation of a curve is y equals 2 plus 3 over 2x minus 1. And we have to obtain an expression for dy dx. So we have to differentiate this expression. So in order for us to differentiate the expression, first we must prepare it for differentiation. So what I'm going to do is I'm going to write this fraction with the x term on top as follows. I'll write this as 3 times 2x minus 1 to the power of negative 1. Because at the moment it's like 2x minus 1 to the power of 1. When you want to write in the numerator, you have to change the power of the change the sign of the power to negative 1. Just like if you had 1 over a, you know that's going to be a to the power of negative 1 and so on. So now to find the expression for dy dx, we have to differentiate both sides with respect to x. So this becomes dy dx. The constant term becomes 0. When you differentiate a constant, it becomes 0. And here we have something which we have to use what's called the chain rule for, where we have like, basically you have something where function within a function. So you have 2x minus 1, okay, within the function something raised to the power of minus 1. So how do you differentiate this main function, something raised to the power of minus 1? Well, we multiply by the power. So you have minus 1 times 3, which is minus 3. And then you take 1 from the power, so you get 2x minus 1 to the power of minus 2. And then you have to be very careful to do something which most, well, not most, but a lot of people do forget, which is multiply by the differential of what's inside the function. If you differentiate by the differential of what's inside the function, you're left with 2. Right? So you end up with negative 6, and we can put this over 2x minus 1 to the power of 2. So just, if we know that a to the power of minus 2 is the same as 1 over a squared, we're using that rule to write this in the denominator. So we end up with our answer, dy dx equals minus 6 over 2x minus 1 to the power of 2. We could have left it as minus 6 times 2x minus 1 to the power of negative 2. That would also be fine. Okay, so there we have our answer for dy dx, and this is the answer for 7 part 1. Now for 7 part 2, it says explain why the curve has no stationary points. Well, we know that the stationary points are the places where the curve has 0 gradient. Stationary points, we know that the gradient is equal to 0. The gradient is 0. So we got to find the points where dy dx is equal to 0. So we have the expression for dy dx of minus 6 over 2x minus 1 squared. We want to solve the equation where this equals 0. Now this is a type of equation, if you try to solve it now, you have to multiply both sides by 2x minus 1 squared. What's going to happen is you're going to end up with something called a contradiction. This is a contradiction. Okay, you can't solve it. Okay, because the x term just completely disappears. Right. So what we can say here is, that dy dx cannot equal 0. Okay, when dy dx equals 0, dy dx equals 0, this is undefined. Okay, all right, so therefore we can say that there is no solution to dy dx equals 0, which means, that means no stationary points. As there's no solution to dy dx equals 0, there are no stationary points. There can be no stationary points because you cannot solve this equation. All right, so there's the answer to part 2. Now for part 3. It says, at the point P on the curve x equals 2, show that the normal to the curve at P passes through the origin. So we need to now have our expression for dy dx, which is minus 6 over 2x minus 1 squared. Let me just make sure of that. Yeah. Okay, so we have our gradient, and they told us at the point P on the curve x equals 2, show that the normal to the curve at P passes through the origin. So just imagine the curve looks like this. Right, some part of the curve, we don't know, I'm just drawing a random part of how the curve could look. And supposing we have a line like this, say that's the tangent to the curve at the point P. Just imagine this is a point P, okay, and this is the tangent to the curve. Now the normal to a curve is a line which is perpendicular to the tangent, but it passes through the same point on the curve that the tangent touches. So this would be the normal to the curve. This would be the normal to the curve, perpendicular to the tangent. So we need to know two things. We need to know the coordinates of point P, and we need to know the gradient of the tangent. If I know those two things, I can find the equation of the normal, and therefore I can then find what I'm looking for. So what I'm looking for is the equation of the normal. So now, first of all, we need to know the coordinates of the point P. So we know at P, we know x equals 2, as they tell us in the question. So we can find out what y is by replacing the x with 2 in the equation for the original equation for y. So 2 plus 3 over 2 times 2 minus 1. Minus 1. Okay, so that's going to give you 2 plus, and that's 4 minus 1, which is 3. So it's 2 plus 3 over 3, which is 2 plus 1, which is 3. So the coordinates of point P are 2 and 3. Right? And the gradient of the tangent to the curve is found by taking the gradient function minus 6 over, and we replace the x with 2 in dy dx. So 2 times 2 minus 1. All right, so that gives you minus 6, and that's supposed to be squared, sorry, minus 6 over, that's 4 minus 3, which is, sorry, 4 minus 1, which is 3, 3 squared, which is 9. So it's going to be minus 2/3. That's the gradient of the tangent. So we know that the gradient of the normal is going to be positive 3 over 2, and the point P is a point 23. So we can say that the equation of the normal is y minus y1 equals m times x minus x1. So y minus 3 equals m, which is 3 over 2 times x minus 2. Okay, so what will happen is, let me just make some more space here. Okay, so what we can do now is we can say that if we try to solve this, we have y minus 3 equals, that's 3 over 2 times x, which is 3 over 2x, and 3 over 2 times minus 2. The 2's cancel, you're left with negative 3. So we end up with y equals 3 over 2x. So we can say as the y-intercept is 0, therefore, okay, it passes, the normal passes through the origin. The normal passes through the origin. Okay, so there we have the answer to part 3 of the question. Okay, now for part 4, it says a point moves along the curve in such a way that its x-coordinate is decreasing at a constant rate, 0.06 units per second. Find the rate of change of the y-coordinate as the point passes through P. So, okay, we have the point P, which is 3, 2. We have the gradient dy dx, which was minus 6 over 2x minus 1 squared. Now, what they've told us is this is one of these rate of change type of questions. Okay, so the rate of change, this would be also saved in a video dealing with rates of change. So what we can say here is they've told us something, all right, that the x-coordinate is decreasing at a constant rate of 0.06 units per second. So they told us the rate of change of x with respect to time in the question, and that's decreasing, so it's negative 0.06 units per second. So that's the rate of change for x, okay, and we want to find that. That's what they gave us. They always give you a rate of change, that's a given rate, and then they give us a rate that we want to find. A rate to find is, as they told us, the rate of change of the y-coordinate as a point passes through P. So they want to find dy dt, okay, they want to find what dy dt is at the point when x equals 2. So x equals, hold on, I think I made a mistake there. So it's actually 2, 3, not 3, 2. Yeah, I wrote it down wrong. Some of you might have spotted that already. It was 3, 2, 2, 3, not 3, 2. That was a point. Good thing that we didn't use it yet so far. Okay, so that's when x equals 2, y equals 3. So we want to find dy dt when x equals 2. When x equals 2. That's what we want to find. Be careful not to make silly mistakes like that. You can mess up the rest of your question there and lose marks. All right, so now, good. So now, how do we find dy dt? So we're trying to find dy dt. So we write dy dt equals. We write down the rate they gave us in terms of its expression, so not in terms of its value. So we write dx dt. And then you say to yourself, what do you need to multiply the x dt by to be left with dy dt? Well, we definitely need a dy on the numerator here, so I have to put dy. And I want to get rid of the dx, so I'll write dx over here. And if you multiply those together, you're left with dy dt. So we know that dx dt, they gave us as negative 0.06. And dy dx, we already found it as negative 6 over 2x minus 1 squared. Okay, so that is going to be dy dt. So we can just simplify it a little bit. Dy dt is given by positive now. You got 6 times minus 0.06. That will be positive 0.06 times 6. Okay. Yep. That gives you 9 over 25. So I'll write it as 9 over 25. So you have 9 over 25 times 2x minus 1 squared. So when x equals 2 is when you have to find. When x equals 2, you've got dy dt is going to be 9 over 25 times 2 times 2 is 4 minus 1, which is 3 squared, which is going to be 9. Okay, because that's going to be 4 minus 1, 3 9. So those cancel out. So you're left with 1 over 25 units, okay, per second. Positive, okay, 1 over 25. If you want to write it as a decimal, you can do that. So you have 1 divided by 25. Okay, that gives you 0.04 units per second. So there's the answer to part 4 of this question. Okay, there's the answer to part 4. It's a typical rates of change, part of the question. So this is something which involves rates of change as well. All right, so there's the answer to question number 9. Other questions from this particular, it's question number, what was it again? It's question 7 from the past paper. So over here you'll find other questions from this particular past paper. You'll find the playlist for that paper here. And for the end of topic worksheet, this particular end of topic worksheet, you'll find the playlist for that in this region over here. You can find other questions dealing with differentiation from P1 here. And I'll put also this in the playlist for differentiation of, in terms of rates of change. I'll put a section up there as well. So I hope that was clear. Thank you for watching and see you soon.